Hi everyone, this is the Math 30-1 Trig 2 review, and this is question 6b. We're going to prove this double angle identity. Okay, now, I'm going to draw that line there because I need to make sure that the left side and the right side are equal to each other simultaneously or independently of each other. Now, in the previous question, I immediately dealt with that double angle identity there, but you know what? Cosine could be equal to three different things. So I really don't know what I want to put here. So I'd be better off working with this side right here and just checking to see which one of those I can link up with. Now, when I look at this the left-hand side here, do I see any Pythagorean identities? Yes, I do. 1 plus tangent squared is secant squared. So this will be 1 minus the tangent squared all over secant squared of theta. Okay, now that's exactly the same as the previous statement there. Now 1 minus tan squared isn't an identity, okay? So I'm going to leave that there. Now, just thinking here what I might do here. There are no other Pythagorean identities because I don't want to start going backwards here and expanding the secant squared back into 1 plus tangent squared. So I want to keep moving forward here. Is there any obvious algebra that I can do? Well, sort of. You know, the thing that we might want to do here is, in this particular case here, I think for a lot of people, what would be very tempting to do at this point is to write this in terms of sine and cosine. And that actually might be not a bad way to go about doing this. So tangent is just going to be sine over cosine. Okay, or sorry, sine squared over cosine squared because it was tangent squared. And secant squared is going to be 1 over cosine squared. Now, I'm taking this term right here and I'm dividing it by this fraction. So that can be rewritten as a product. So 1 minus sine squared over the cosine squared of theta, all multiplied by the reciprocal of that denominator, so cosine squared over 1. Now, when you distribute that through, you are going to get, can't see that. When you distribute that through, you're going to get cosine squared of theta. And here, for the second term, the cosines are going to cancel, and we're just going to be left with minus sine squared of theta. But that's great. That's exactly what I want, because one of the expressions for cos of 2 theta is cosine squared minus the sine squared. And so there we go. We've been able to demonstrate, kind of independent of each other, that both sides of this identity are equal.